afternoon, everyone. Continuing the miniscript journey, I'll talk about miniscripting in the Covenant world. So now we have good background of miniscript, thanks to Rob and Randy for conveying what miniscript is. This talk is mostly experimental on our adventures at Blockstream previously, trying to extend miniscript with Covenant functionalities and things we learned doing those experiments. So yeah, a brief outline. Will first look at existing proposals, just quickly go through them, look at miniscript, although we might skip that section in light of what we just recently covered, see how miniscript translates into Covenant world, and look at some of our practical examples where we tried to do Covenants using the miniscript paradigm, and some lessons learned from those and what we can use those to justify new or evaluate new Covenant proposals. So it's just a slight segue, but opcat is everyone's discussing about that quite frequently. It just, I don't need to go into too details, but it just concatenate two things, and it's surprisingly powerful in conjunction with existing primitives, and it's active on Signet. And people are scared of cats for for some reason. But what I want to highlight here is that cat by itself is not scary. It's actually checksig or checksig verify that is at fault here. But there's nothing we can do about it. But in a hypothetical world, let's just imagine another design of Bitcoin, maybe SegWit-V2, or just let's just see what happens if we have two separate stacks. One of them is a mutable stack where we just changes according to script operations, or duplicate things, add things, stop things, and we have a separate signature stack, and that only the checksig opcode can take the signature from that stack, and that is immutable. Once you take that signature, you cannot mutate that stack using your regular script operations. And suddenly cat becomes less interesting. We can still do thresholds, multisigs, and all the complex things which we want to do in this model, but just that we cannot use cat or to construct these funky signatures with one of them being G, or concatenating weird things to create sig hash in a separate way. So yeah, what we actually want is really access to script transaction data in a more programmatic way, and that's what Rusty covered in the keynote talk with making the revival of script. And we want to do unvaulting, where check whether the amount that you are unvaulting is greater than some value, or check whether participants in coin pools are using them correctly, constraints on destination addresses, and so on. But so this is what we actually want, and cat gives us an indirect way to get it. So even this is a brief overview of the other opcodes. I'm sure people are familiar with it, but CTV is where you can enumerate all of the spend conditions right at the commitment time, and you can escape out of that covenant after all your escape routes, and eventually you can get out of that covenant. Vault is a specific application-specific covenant which just does vaulting and does it pretty good. APO, or any prevout, is on the other side, where instead of using opcodes to restrict or to get access to this transaction data, you use a different paradigm using sig hash flags to control the way in which parts of your transaction can be fixed and which parts can be not covered by the signature. And simplicity takes us to an extreme with a universal sig hash, where you can at redemption time decide what things you need to sign and what things you do not to sign, and even functions on those things. And the other one, we have introspection and arithmetic opcodes, where you can put things like transaction amount, transaction script up keys, addition, crypto opcodes, and stuff like that. And want to relate these to miniscript. I will, in interest of not having another miniscript thing, I will skip this it's because we have had 2 talks of miniscript. It's just similar. It's the received HTLC thing. I think Rob highlighted it correctly. We, instead of having something like this, we have a tree structure, which just adds more structure, gives us analysis and these nice properties, which is like, yeah, going through this quickly. So we can reason about, in particular, so we have these subset of primitives that we are interested in: keys, hash logs, time logs. We can reason about correctness and malleability. These things are easier to write. We can do lots of static analysis on different spend paths. You can do like what we call generic signing, is like sign for policies which are composed in other policies without really understanding what the entire thing is doing. And much more. But if we include covenants in the picture, suddenly they're still easier to sign. You can do generic signings. You have you have more functionality apart from keys, hashes, but we do lose some things. In particular, we cannot really reason about correctness. This is because like in miniscript, all the reasoning is like based on the local subtree or local-based reasoning based on the combinations of the different fragments, and that is not possible because suddenly you have access to this global structure of transaction data that you cannot reason out with just like script local things. You need some other tool or something such as like Dimitri's BSST to reason about security of his script, because it's not entirely dependent on the contents of your script, but it's more of like even in some cases inter-transaction logic, and by looking at the script, miniscript might just say it's an anyone can spend, but it is guarded by different logic across that spans multiple transactions. So when we like extend it across this paradigm, so just the easy property which we get from miniscript where we can reason about security and correctness is just like we lose it. But I heard Randy's complain about like miniscript is not extensible, so we did some work on top of it where we tried to allow users to bring their own fragments into miniscript. So you can specify information like, this is my new fragment. This is how much, for example, in Jeremy's case, it would be, this is a CTV fragment. It takes the script pub key is 33 bytes. It pushes these things on stack on satisfaction. And this is how you would check its satisfaction. These are the worst case limits. And you would provide how you would parse and serialize them. And you can use them in the miniscript model in conjunction with all your existing primitives. So an example of this might be a simple miniscript where we allow spending either from key A, but if key B has to spend, the amount has to be less than 10 cents. It's a dumb covenant, but the point is you can write your own leaf fragments for your own custom use cases in the post-covenant land and extend it with CTV or any of the other ways you want to build them. And we're going to take a look at how the tooling might look for this in 2 particular scenarios in particular. One of them is cat and checksec from stack, and this is like the old way of doing covenants. People can just do it with cat, but for ease of explanation, I'm going to include checksec from stack. It's simpler to explain and understand. Essentially, the idea is like you ask the user to supply transaction data, and then you authenticate that transaction data and make sure that the transaction data is actually the signature message that you signed. So I have some animations which help understanding how this paradigm works. So we have this TX data blob and signature that's already a part of our witness stack, and then we have this as our script that we plan to execute. And we can just step through this one by one and see how it executes. So first, like the hop over just pulls the TX data on top of the stack. We hash that transaction data. We add a public key, and that's the first line. Then we just picks the second to last element, which is the signature in this case, and puts it on top of the stack. And we again concatenate that signature with 1, which is our sig hash all flag, which states that you want to sign all the transaction data. And then we have the public key on stack top. So with this, with the 2 lines of script that we looked previously, we have this stack construction. And note here that the public key is duplicated from this public key, the signature is duplicated from this signature, and the TX data is hashed from this TX data. We did all of these computations on stack. And now we are going to verify that this check, that the same thing satisfies the check sig paradigm and also satisfies the check sig constraint, which is this, and also satisfies the check sig from stack. So by doing all of this funky dance, what we have is that the TX data on stack is the same TX data that we had, is the same TX data that a transaction has, because the same signature with the same key is valid for exactly 1 message, and we did 2 different checks on them. One of them was checking that the same transaction data hashed with the check sig from stack, which are artificially constructed transaction hash, and other was check sig, which Bitcoin does by itself. And this is how we can be sure that we have this, the true TX data on stack. And extending that a step ahead, we can like decompose these transaction data into like the SegWit signature hash message. This is specific to SegWit, but we can do the same thing for Taproot. So user would provide all of these data as inputs to the stack, which is the 10 elements that are defined in like SegWit signature hash. And we would run this prelude script, which is the script that we saw in the previous slide that would essentially authenticate all of this data. And after you run this, what you have is a like our script, our transaction elements in particular positions in stack. So if you want to know what transaction version is, that is at position 0 in stack. If you want to know what the inputs hash is, it's at position 2 in the stack. Lock time, outputs, and you can use that serially to like access the different elements from the transaction data. So think of it just like regular programming variables. You have access to transaction data from like that is just included as a part of running your script prelude, and you can now run things to do a rough CTV, approximate CTV it might be. You can just check that outputs hash is equal to certain element, and that is almost what most of what CTV does. And you can check version inputs and all the additional things. So that's running this prelude script would give you access to these variables. You can use them as fragments in your miniscript script. So yeah, this is really inefficient. We don't want to do this. Like it's 75 opcodes of running all of these things, and it restricts the numbers of inputs and outputs because the transaction stack limit is 520 bytes, and without streaming opcodes, you cannot have more than that. So if your outputs hash field, the pre-image of that is more than 520 bytes, it's hard to reason about that. You can do funky tricks with code separator if your script size is more than 520 bytes, but still it's limiting, and it's a hacky way to go about it. But we did, even despite these limitations at Blockstream Elements, we did build an application which supports creating options on elements chain, which has multiple assets. So you can create options, you can exercise, cancel, spend, and like using this miniscript tooling which we showed previously and writing descriptors, you can express complex conditions by setting up the stack as shown. But and now we're going to take a look at building the same application but with the new introspection opcodes. This is so instead of having like a special purpose opcode like CTV, Vault, we would have like many opcodes which would like say fetch me the input amount at input index I, fetch me the output amount at output index j, streaming SHA-256 opcodes, arithmetic opcodes, opcodes for doing crypto operations, and there's a spec in Elements repository for which specifies how exactly these work. And I think there's also a proposal in Bitcoin land to like use a subset of these to do 64-bit arithmetic and output introspection. So the way these would again translate into miniscript is you'd have new fragments using the same bring your own fragment paradigm, where you can inspect input script pub key, inspect output value, and use those in your as a miniscript fragment, and even compose them using ands or thresholds like we regularly do in miniscript. The simple example here is like you can check whether the input script pub key is equal to the output script pub key. That's like the simplest form of recursive covenant. And this is a example which again, in the same, using miniscript, which is built by one of my colleagues, Alan, it demonstrates how we can build complex applications like, trading financial derivatives like options using simple script. And this is again in the same miniscript paradigm with output introspection opcodes, and doing this is like way easier if we have direct access to these opcodes. Yeah, and lastly, I want to spend some time for because we did spend a lot of time implementing one of them using the previous check from stack and cat paradigm, and also implementing this again on using the introspection opcodes. Both of them are available for you to try at the Elements miniscript repository or options repository respectively. So I welcome you to try them, and I want to just share my learnings based on these experiments and see how we can use that for evaluating more proposals. And yeah, the number one thing is you need accessible scripting. You need tools for you need developer tooling. You have to debug things when things don't go wrong. Bitcoin Core would just throw verify failed, and you don't know where it is in your 500 byte line script, and you still struggle. It does not really provide much context around where things should be. And the third point is more relevant to our current conversations around what trade-offs we should be making. And in my opinion, it's okay to be slightly more expensive if it means that everyone can build more easily on it. And without explicitly calling out, I think most people agree that X-only keys in Taproot were a development nightmare. If you have built wallets on top of, or if you have written tooling there, it would yeah, if you wrote tooling there, it would be, it's not a good experience. And trying out particularly music aggregations and complex things on top of it, maybe saving 1 byte is not worth it if you can reuse all of your existing tooling to support them. We want spend conditions to be more composable. So if we have a cat-based vault or a cat-based vault construction, and suddenly it does not work with a threshold setup or custom recovery conditions or coin pool participants where we want them to have their own multisig, or vaults inside coin pools, coin pool inside vault, these are conversations which should have before we activate any of these proposals, because we do want them to work out of the box for several wallets that support PSBT, that understand what they need to sign. But if you have this janky program with just cat and does weird things and it doesn't necessarily compose well, it will prove hard to work with. Lastly, if we have simple primitives, it's in our nature to design things that are simple at the base layer. Simplicity takes one approach. Bitcoin script takes one approach. The complexity naturally flows somewhere. You cannot hide from it. The complexity goes up into tooling and applications. And even adding a small bit of functionality at the consensus layer improves the lives of developer upstream significantly. So this is something which we should be more open to discussing, where maybe it's slightly inefficient we don't need the very best thing at the consensus layer, even if it is slightly inefficient and it on not only two people can write like mini script or some other thing. It would be good if everyone can just like do the thing right there without having to go through tooling layers which are hard to maintain and maybe don't have the best debugging experience. And yeah, whether it's like when we add new covenants or discuss these new things, there's always constraints about like recursive covenants, bug in implementation, map from covenants. Like, why do you want to add complexity? Just keep it as simple as possible. And yeah, I get that all these are valid constraints, but again, this is, in my opinion, as a user of Bitcoin, like as a Bitcoin node, you should not care about what other people do with their own UTX. So as long as like they satisfy some basic properties, and I made my best. Again, this is a result of conversation with different people, but this is my best characterization of what an average Joe who does not care about covenants, and people are working with them, if they do not satisfy any of these properties, you have a good reason to go and shout on Twitter like, no, you're making my Bitcoin experience worse by enabling these properties. So first, like script result should be a function of transaction itself, which means you should not have any global mutable state. Example, if you suggest adding a covenant which looks at, let's say, which is valid only if certain other transactions are valid, or which sets a global variable which undoes transactions which you previously accepted. So that just like messes up with the mempool, with how mempool works currently, and now you have to revalidate the entire blocks, and suddenly the block validation becomes slow. And like all of these are valid concerns which translate if your script has access to or is dependent on more data than transaction itself. And secondly, you should be sure that like static analysis of resources for what you need to evaluate the script. So right now we have a good understanding just by looking at Bitcoin script, the length of Bitcoin script. We can be sure that one opcode is executed exactly once, like without the for all inputs and stuff like that. But right now we just have one opcode executed exactly once. This is the cost, and we can bound it just by looking at the length. And just by looking at the length, which means fee is bounded, so we can say that fee accurately represents the resource cost. And if these two properties are satisfied, we should not complain about solutions which if they may not be useful to you, but they wouldn't be damaging your node, which is a participant in the network. On the opposite side, we want, so what does it take? So this was something which is, in my opinion, if you don't have these, I will actively oppose your proposal. But this is something which is, if you have these, I will actively support your proposal. As the number one is purpose. That's what we discuss the most. Like you want to do use cases that you're interested in. I'm interested in the self-custody aspect the most, and CTV vaults prove short of it in terms of like, they didn't have support dynamic fees. Opvault does that cleanly. You want people to reason about your script. So first 2 points is, I think, where we do a really good job at, as a community, evaluating new proposals. But the second and third parts are, I think, where we can try to do better. Like, can you start developing just on top with existing tooling? I don't know. Like, I know there's lots of people who are pushing for CAT, and there's like 5 use cases listed on the CAT web, but I would be surprised if more than 5 people in the world can actually implement all those 5 use cases. Like, that's I know we can hide by this by providing more accessible tooling, but at some point, as every programmer knows, you have to break through these layers of abstraction to understand what's going on and to see what's going on. And if you can't do that, then that by itself would be like would not be sufficient. And we should also think about like, can these spend conditions be composed in like not in any possible, ideally using mini script, but in any possible way. You should not be stuck to using one specific wallet, because that is like that supports this weird chunky CAT scripts. Now, but I also want like any hardware wallet which just has a key to understand and sign that particular part of it. Yeah, I think those were my opinions on the last few things on how governance should involve and how they can look at the manuscript world. So any questions, please? Thank you.